everyone, and welcome back for another deep dive. This time we're looking at something pretty incredible, the Xpeng X2.
The Xpeng X2.
Yeah. It's a flying car, well, kinda. I've got a ton of sources here, like articles in Italian and English, spec sheets, and even a YouTube transcript about it.
Wow, lots of material.
It's a lot, but that's why you're here. I'm super curious about this thing, especially with an expert to help me understand it all.
Happy to help. It really is a fascinating piece of technology.
So when I hear flying car, I immediately think like Back to the Future, you
Yeah.
know, like, is this really happening?
Yeah, I get that. The term flying car gets thrown around a lot. But what we're really dealing with here is what's called an eVTOL.
An eVTOL. Okay, so what is that?
It stands for Electric Vertical Takeoff and Landing Vehicle.
So like a helicopter.
Kind of, but the key difference is how they take off and land.
Yeah.
Helicopters need a runway or a helipad,
Right.
which
Yeah.
makes them kind of impractical in cities.
Yeah, totally.
But eVTOLs, they take off and land vertically, like a drone. So they could operate from rooftops, parking lots, even maybe your backyard.
That is so cool.
It is. It's very adaptable, especially for cities.
So, okay, is this X2 the only eVTOL, or have there been others?
There have been other attempts at flying cars, some more successful than others.
Like what?
Well, you've probably heard of the Aero car.
The Aero car from way back.
Yeah, the 1950s. It had these detachable wings that folded up when you were driving on the road.
So it was a real transformer, like drive to the airport, attach the wings, and fly away. That's wild.
It was a cool concept, but they faced some, well, challenges. Safety, regulations, cost.
They were probably really expensive, right?
Yeah, way too expensive for most people.
So are we saying the X2 is different?
Well, the X2 benefits from decades of advancements in technology, especially in electric propulsion, autonomous systems, and lightweight materials, all things the Aero car didn't have.
All right, so the X2 is different. Tell me more. Like, what sets the X2 apart from maybe other eVTOLs?
Well, one thing that stands out to me is Xpeng's focus on safety. Like, they built in multiple redundant systems, so even if one rotor fails,
Oh, wow.
the vehicle can still land safely. And there's a ballistic parachute, just in case.
Oh, okay. That makes me feel a little better.
Right. I'm not sure I'd trust my parking skills to land a flying car.
Not me either.
But, you know, landing is something that city planners are actually working on right now, figuring out the infrastructure.
Really?
Yeah, they're calling them vertiports,
Yeah.
basically landing pads built into buildings or structures. Imagine skyscrapers with rooftop landing pads.
Whoa. That sounds kind of futuristic.
It does, doesn't it?
Okay, back to the X2 itself. What does it actually look like?
It's got a sleek teardrop shape, not just for looks, that helps it move through the air more efficiently.
Oh, cool. So it's aerodynamic.
Exactly. And it's made of really strong, lightweight stuff like carbon fiber and aeronautical aluminum.
Okay, so strong but light. Makes sense. What about how fast it goes and how far?
It can hit 130 kilometers per hour. And it has a flight time of about 35 minutes.
35 minutes? That doesn't seem like a lot of time in the air.
Well, remember, it's for getting around a city. Plus, battery technology is constantly improving.
True. So is this something everyone will have one day? Or is it more for, like, air taxis or something?
It's tough to say. Some see it as personal transportation. Others see it more for things like cargo delivery or air ambulances.
Oh, interesting. That makes sense.
The applications are pretty vast.
So we've talked about what makes the X2 different and these vertiports. But we talked about the Aero car earlier. Were there other attempts at flying cars before?
Oh, absolutely. The dream of flying cars has been around for a long time. There have been tons of attempts. And, understanding those can help us appreciate what the X2 is doing right now.
Okay, so what were some of the biggest attempts before the X2, and why didn't they work out?
Well, one of the most famous was the Terra-Fugia transition. It was more modern than the Aero car, but it still struggled with regulations and affordability. Just like the Aero car, really.
It sounds like practicality and cost have always been the big problems.
It seems that way, yeah.
Okay, well, this has been super helpful. So we talked about how eVTOLers are different, the potential for vertiports, the X2 safety features, and even a bit of flying car history. I feel like we're just scratching the surface here.
We are. There's a lot more to explore with the X2.
Where should we go next with this?
I think it's time to dive into the tech that makes all this possible. Like, how does electric propulsion actually work?
Okay, let's get technical.
Welcome back. So before the break, we were talking about those earlier attempts at flying cars.
Yeah, like the Aero car and the Terra-Fugia, it seemed like they just couldn't quite get it right.
Yeah, and The X2 has the advantage of coming after decades of tech advancements, especially with electric propulsion.
Okay, let's talk about that. I remember reading that the X2 is all electric, like no gas at all.
Exactly. And that's huge for eVTOLs.
Yeah.
Electric propulsion just makes so much more sense.
How so?
Well, for one, think about the noise. Imagine if all those flying cars had loud combustion engines.
Oh, yeah. That would not be very peaceful.
Right, like it would defeat the whole purpose of flying above traffic if
Mm.
you're creating a ton of noise.
So it's quieter. What else?
Well, electric means no exhaust fumes, zero emissions while it's flying, which is a big deal, especially in cities.
Oh, for sure. Cities could really use some cleaner air. So quieter, cleaner, I'm guessing more efficient too.
Absolutely. Electric motors are just incredibly efficient at converting energy into power. So longer range, lower costs.
Okay, that makes sense. But how does it actually work? Like, what's powering this thing?
So the X2 uses what's called a distributed electric propulsion system.
Distributed.
Yeah, basically it means it has multiple smaller electric motors instead of one big one.
Interesting. So why multiple motors? Why not just stick with one?
Well, first off, it's safer. If one motor fails, the others can pick up the slack so you can still land.
Oh, that makes sense.
And it makes the X2 way more maneuverable. Each motor gets control independently so it can make really precise movements.
So it's like having multiple tiny little thrusters all working together. That's so cool. But all those motors must need a ton of power.
They do. That's where the battery comes in.
Okay, so what kind of battery are we talking about here?
It uses lithium-ion batteries,
Hmm.
similar to what you see in electric cars, but these are specially designed for flight.
Right. And we talked about the flight time being about 35 minutes.
Yep.
Okay, so not exactly for long trips, but what happens when the battery gets low? Do you just have to land wherever you are?
Well, the X2 has a system that's always checking battery levels. It'll alert the pilot, or in this case the autonomous system, that it's time to land and recharge.
Wait a second, autonomous system. Are you saying this thing can fly itself?
It can. That's actually one of the coolest features of the X2. Passengers just put in their destination, and the X2 does the rest. Takes off, navigates, lands, all on autopilot.
Whoa. So, I could hail a flying taxi and just sit back while it flies me across town. No more traffic. Sign me up.
Well, that's the idea. It's definitely a compelling vision. But autonomous flight obviously raises some big questions about safety, right?
Yeah, for sure. How do we know it's going to be safe? What if something malfunctions?
That's why the X2 has tons of backup systems and fail-safes. Multiple sensors, processors, everything is redundant. So even if one part fails, it can still operate safely.
So it's like having a co-pilot constantly double checking everything.
Pretty much.
Right.
And on top of all that, there are also regulations being developed to govern autonomous flight.
Okay, so it's not just a free-for-all up there. Someone's making sure these things are safe.
Exactly.
Okay, but I gotta be honest, I'm still a little nervous. What about those rotors? This seemed kind of dangerous, right? Spinning around up there.
You're right. Those rotors are critical parts of the X2. They have to be carefully engineered and maintained.
So they're not just flimsy propellers.
No, not at all. These are high-tech blades. They're designed to be super efficient and stable, made from materials that can handle a lot of stress.
And even if one fails, there are multiple motors, right?
Right. And on top of that, remember the ballistic parachute we talked about?
Oh, yeah. The ultimate backup plan. Okay, maybe I'm starting to feel a bit better about this whole flying car thing.
It's understandable to have some reservations. It's new technology.
So to actually fly one of these things, do you need to be a pilot?
Right now, yes. The regulations require a pilot's license to operate an eVT,
Okay.
but as these autonomous systems keep getting better, who knows? Maybe one day it'll be as easy as driving a car.
Wow. Okay, so let's shift gears a bit here. We've talked about the X2 itself, but what about the bigger picture? How could flying cars change society?
That's the really interesting part. Think about it. Cities could be totally different. We could have skyscrapers designed with vertiports built right in. Rooftop restaurants could become landing pads for air taxis.
It's like something out of the Jetsons. But wouldn't all those flying cars just create traffic jams in the sky?
That's a good point. That's why we'll need really advanced air traffic management systems to keep everything organized and safe.
So it's not just a matter of letting everyone take to the skies.
No, it's way more complex than that. We're talking about a whole new dimension of air traffic control. Lots of algorithms, sensors, communication networks, all working together.
This all sounds incredibly complex. Are we really ready for this?
It's definitely a challenge, but we've overcome some pretty big challenges before, right? We landed on the moon, created the internet.
True, when you put it that way.
Mhm.
Okay, so let's assume we can figure all this out. What are the biggest things standing in the way of actually having flying cars everywhere?
Well, cost is a big one. eVTOLs are still pretty expensive. The X2 is expected to cost over $100,000.
Wow. Yeah, that's not exactly affordable for most people.
Right. And then there's infrastructure. We need to build all those vertiports and charging stations.
So it's not just about building the cars. There's a whole ecosystem that needs to be built around them.
Exactly. And then, of course, there's public perception. Are people actually ready for flying cars buzzing around all the time?
That's a good point. Some people might be nervous about safety or noise.
Yeah, and privacy is a big one, too. All those flying cars will have cameras and sensors. So how do we protect people's data?
So it's not just a technological challenge, it's a social one as well.
You got it. It's about getting people comfortable with this technology and showing them how it can benefit everyone.
Okay, that's a lot to think about. But I still can't help but get excited about the possibilities. Imagine just flying over traffic, exploring new places so easily.
I know what you mean. There's something so appealing about flying cars, right? It's about freedom, exploration.
Yeah, it's like a whole new level of freedom. But we can't just ignore those downsides we talked about.
Absolutely not. We need to address them head on.
So we need to be both excited and cautious.
Exactly. It's about finding that balance.
Okay, so we've covered a lot here. The Xpeng X2 itself, the challenges of autonomous flight, air traffic management, the impact on society. But before we go any further, I want to go back to something we talked about earlier. Like, remember how we said the X2 is learning from the mistakes of those earlier flying cars?
Yeah, those past failures are important to learn from.
So what did we learn? What makes the X2 different? Is this finally the moment when flying cars become real? Welcome back to the deep dive. We've been talking all about flying cars and specifically the Xpeng X2.
It's some pretty mind-blowing stuff, isn't it?
It is. We've covered the tech, the potential impact, even went back in time a bit with the Era car and Terrafugia.
And how those earlier attempts just didn't quite take off.
Right. But you know, I have to admit, even though I'm excited, I'm also a little worried.
Worried.
Yeah. We've talked about all the good stuff like less traffic and cleaner air, but what about the bad stuff? What are you worried about?
Well, one thing that concerns me is, inequality. What if only rich people can afford these things?
Oh, yeah. Like a flying car just becomes another luxury item.
Exactly. And then you have this world where the wealthy are zipping around in the sky and everyone else is stuck on the ground.
That wouldn't be good, so how do we prevent that?
Well, policymakers have to be really smart about this. Maybe there are subsidies or public transit systems for flying cars or ride-sharing programs.
So making sure everyone has access to them, not just the rich.
Exactly. But even then, there are other worries, like we talked about all those flying cars needing air traffic control.
Right. But what about noise? Imagine a sky full of buzzing cars.
That's a valid concern. And engineers are definitely working on quieter eVTOLs.
Right. But they can't be silent.
Probably not. So that means we need to think about things like designated flight paths or maybe restrictions over certain areas.
To keep the noise down.
Yeah. And to make sure we're not ruining the quality of life for the people on the ground.
Makes sense. And what about privacy? I mean, all those cars will have cameras and sensors.
That's a big one. We need to have really clear rules about who gets to see that data and how it's used.
So we're not all being spied on from the sky.
Exactly. It's about using this technology responsibly.
Okay, so inequality, noise, privacy, those are some serious things to consider.
They are. We can't just pretend those problems don't exist.
But even with all that, I'm still excited. Imagine just being able to fly over traffic, explore new places so easily. It's a whole new level of freedom.
It is exciting, isn't it? It taps into that desire we all have to explore and push boundaries.
Totally. So maybe it's not all bad.
No, it's not. It's about finding that balance,
Yeah.
being excited about the possibilities, but also aware of the risks.
So cautious optimism.
I like that. Cautious optimism. We need to be asking tough questions, but also working together to make sure this tech benefits everyone.
Okay, I think I can get on board with that. So where do we go from here? What are the next steps?
Well, I think the most important thing is to keep talking about this stuff, to have open conversations about what flying cars could mean for our future.
Not just scientists and engineers talking, but everyone.
Exactly. This is something that affects all of us.
That's a great point. Well, I think we've covered a lot of ground today. We talked about the Xpeng X2, the challenges, the potential impact. Any last thoughts before we wrap things up?
Just this. Keep looking up. Keep dreaming about what's possible. The future is coming, and it's going to be amazing.
I love that. Keep looking up. And on that note, thanks for joining us on this deep dive into the world of flying cars. It's been a wild ride.
It has.
Thanks for listening, everyone.